For most people, jet engines are invisible. You hear them, you trust them, and you never think about what's happening inside. But behind the scenes, the global aviation industry is locked in a quiet arms race. There are only a handful of companies capable of building large commercial aircraft engines, and every new breakthrough can reshape who dominates the skies for decades. That's why, when Rolls-Royce revealed a major milestone in its UltraFan program, it instantly sent shockwaves through the industry. This wasn't a routine update. It was a signal that one of aviation's oldest players is preparing to rewrite the rules once again. Rolls-Royce didn't start as a commercial aviation giant. Its roots lie in war. During the First World War, its Eagle engines powered British bombers and transport aircraft, establishing a reputation for reliability under extreme conditions. That reputation only grew during the Second World War, when the legendary Merlin engine became the beating heart of aircraft like the Spitfire and Hurricane, helping decide the outcome of the Battle of Britain. Those engines didn't just win contracts. They cemented trust, something far more valuable in aviation than raw performance. When the war ended, that world disappeared almost overnight. Propellers gave way to jets, and companies that failed to adapt were left behind. Rolls-Royce survived by reinventing itself. Early jet engines like the Derwent powered Britain's first jet fighter, while the Navy became one of the most widely exported jet engines in history, flying on both Western and Soviet aircraft. This period quietly transformed Rolls-Royce from a wartime specialist into a global aviation powerhouse. But the real turning point came decades later, with an engine that nearly destroyed the company. The RB211 program in the 1960s pushed engineering boundaries too far, too fast. Costs exploded. Development stalled. Rolls-Royce collapsed financially and was nationalized. Yet out of that crisis came something revolutionary: the Hyperpass turbofan. It was quieter, more efficient, and better suited to commercial aviation than anything before it. That design became the foundation of modern air travel. Still, even that breakthrough had limits. As engines grew larger, engineers ran into a hidden problem. Every major section of a jet engine, the fan, compressors, and turbines, wants to spin at a different speed. Most manufacturers accepted a two-shaft design as a compromise. It worked, but not perfectly. As fans became enormous, their tips risked approaching supersonic speeds, increasing noise, stress, and wear. Efficiency gains began to flatten. Rolls-Royce refused to accept that ceiling. Instead of compromising, it took a radical step. Engineers added a third shaft, allowing each major section of the engine to spin at its ideal speed. This three-shaft architecture was unconventional, complex, and risky. But it worked. Noise dropped. Fuel efficiency improved. Mechanical stress was reduced. That design became the backbone of the Trent engine family, which went on to power wide-body aircraft across the globe, from long-haul twins to the massive Airbus A380 for years. The Trent engines defined Rolls-Royce's dominance. But even that success wasn't enough. Fuel prices rose. Environmental pressure intensified. Airlines demanded more efficiency without sacrificing reliability. Incremental upgrades were no longer sufficient. A deeper rethink was required. That rethink quietly became the Advanced program, and at its peak, UltraFan isn't just a new engine. It's a new architecture. Engineers began by questioning everything: materials, manufacturing, airflow, and even how engines are assembled. Tens of thousands of components were redesigned using additive manufacturing. Massive parts were 3D printed to reduce weight and complexity. Ceramic matrix composites were introduced to withstand extreme temperatures while remaining lighter than metal alternatives. These weren't cosmetic changes. They were foundational. The results were staggering compared to earlier Trent engines. The technology behind UltraFan promised fuel efficiency improvements of up to 25%. That's not a small gain in aviation. It's the difference between profitability and loss on long-haul routes. And this was before the engine even reached its final form. When Rolls-Royce finally revealed UltraFan, the scale alone captured attention. Its fan diameter reaches up to 140 inches, larger than any commercial engine currently flying, even surpassing the GE9X. Those massive fan blades are made from carbon composites with titanium leading edges, cutting hundreds of kilograms from the engine's weight. A larger fan means a higher bypass ratio, and UltraFan pushes that ratio beyond 15 to 1, one of the highest ever achieved. The real gamble is the gearbox. By introducing a geared system, UltraFan allows the fan to spin slower while the turbines operate faster, each at their optimal speed. This reduces noise, improves efficiency, and lowers fuel burn. Gearboxes at this scale are brutally difficult to engineer. They must survive enormous torque, heat, and vibration for years. Rolls-Royce didn't add one lightly, but by doing so, engineers were able to reduce the number of turbine stages, simplifying the engine and cutting even more weight. On paper, UltraFan doesn't chase raw thrust records. It tops out around 100,000 pounds of thrust, below the most powerful engines ever built. But that misses the point. UltraFan isn't about brute force. It's about doing more with less. Compared to current large turbofan engines, it's designed to deliver up to 20% fuel savings per flight. Over an aircraft's lifetime, that's billions saved and millions of tons of emissions avoided. And that leads to what may be UltraFan's most important feature: sustainability. Rolls-Royce has already tested the engine, running entirely on 100% sustainable aviation fuel, not blends, not partial substitutions, full SAF. That alone could reduce life-cycle carbon emissions by up to 80%. In an industry under immense pressure to decarbonize, that capability changes conversations at the highest levels. Of course, technology alone doesn't put engines in the sky. Certification remains a brutal process. UltraFan must prove it can operate safely under the harshest conditions imaginable. Rolls-Royce plans to conduct flight tests using a modified Boeing 747, gathering mountains of data before any commercial launch. Timelines point to the late 2020s or early 2030s, assuming everything goes right. That raises the biggest question of all. What aircraft will UltraFan power? Officially, nothing has been announced, but speculation is already swirling. Some believe it could anchor a future wide-body revival. Others suggest it may be scaled to power an entirely new generation of aircraft. Rolls-Royce has confirmed the concept is modular, capable of covering thrust levels from narrow-body jets to the largest wide-bodies ever imagined. That's what makes UltraFan different. It's not just an engine, it's a platform, a foundation for decades of development. If successful, it could quietly replace the entire Trent family and reshape how future aircraft are designed. Aviation rarely changes overnight, but every so often, a breakthrough shifts the direction of the entire industry. UltraFan looks like one of those moments, and if Rolls-Royce delivers on its promise, the engines powering tomorrow's flights may owe their silence, efficiency, and sustainability to a decision made today to refuse compromise and chase something better. And that refusal to compromise is what keeps UltraFan so fascinating. Because while most engine programs are tied to a single aircraft or a narrow market window, UltraFan is being built as something far more flexible. Rolls-Royce has made it clear that this isn't a one-off experiment. It's a scalable platform. One core architecture that can be stretched, downsized, or adapted to power an entirely new generation of aircraft that don't even exist yet. That matters because aviation is approaching another crossroads. Narrow-body jets are being pushed to fly farther than ever. Wide-bodies are being scrutinized for cost and efficiency. And airlines are under pressure from every direction: fuel prices, emissions targets, noise regulations, and public perception. An engine that can adapt across multiple categories gives manufacturers options they haven't had in decades. There's also a strategic angle most people miss. Rolls-Royce has long dominated the wide-body market, but largely stayed out of narrow-body engines. UltraFan quietly changes that equation. With confirmed scalability from roughly 25,000 to over 100,000 pounds of thrust, the same core technology could one day challenge competitors in segments Rolls-Royce has never seriously played in before. That's not a guarantee, but it's a warning shot. Of course, the risks are enormous. Gearboxes at this scale are still rare. Certification timelines are unforgiving, and airlines are famously cautious when it comes to adopting unproven technology, no matter how promising it looks on paper. One unexpected issue in testing could push timelines back years. Rolls-Royce knows this better than anyone. Its history is filled with breakthroughs that came at a painful cost, but there's a reason the industry is paying attention. UltraFan isn't chasing marginal gains. It's aiming for a step change. Lower fuel burn, lower noise, lower emissions, and an engine architecture designed around the realities of future aviation, not the constraints of the past. What makes this moment especially interesting is timing. By the time UltraFan is ready for service, the aviation landscape may look completely different. New aircraft programs could finally move forward. Airlines may demand engines capable of running exclusively on sustainable fuels.